While Dr. Colton works late at night, we wanted to give him a light of inspiration in his office. What better way than a Bob the Builder candle? Only one thing left to find out. Can we build it? Step 1. Calculate the critical mold dimensions. Like any engineering project, we started with pencil, paper, and governing equations. We wanted to make a bottom-gated mold to encourage laminar flow and reduce splashing. We chose a 2-inch mold height as to not burden Dr. Colton with too heavy a paperweight. Most of the difficulties in calculations stem from finding the properties of the paraffin wax. With the help of academic papers and undergraduate thermo textbooks, we were able to find what we thought were reasonable estimates for the respective values. Using these properties with Bernoulli's, Lavoisier, and Reynolds, we were able to generate a MATLAB script to determine the gate, runner, and riser geometries. Using these geometries, we could plug them into SolidWorks and create a 3D mold model to 3D print. Step 2. Print the mold. A resin printer was used to make our mold because of its high print quality. All that was left was to manufacture. How poorly could that go? Step 3. Prepare the wax for pouring and construct the mold. Armed with our mold and candles, it was finally time to get building. We took our anger out on the store-bought candles to loosen the wax and heated it over the stove. To assemble the mold, we first tried screwing it together. Despite initial failures, Dongjun felt like maybe we could drill the broken piece just a little bit more. With screws out of the question, we used a much less heat-resistant fastener, rubber bands. Step 4. Pour the wax in the mold. With all of our safety gear on and an abundance of caution, we commenced the pouring procedure. Step 4.5. Pour the wax around the mold. It was immediately clear that we did not make a large enough pouring basin, but the wax puddle on the outside of the mold did help to insulate and prevent short shots. It did cause some of our rubber bands to snap due to heat, but nothing a couple more couldn't fix. Our bottom-gated mechanism worked great to prevent splashing, as long as you neglect all the splashing around the mold. By our calculations, the wax should take around 35 minutes to solidify at room temperature. Our calculations were wrong. Perhaps because we never measured the wax temperature. I, for one, was not going to volunteer my only thermometer for this one-way trip. Step 5. Cool the wax. Make sure to keep your eyes on the mold so it doesn't run away when you're not looking. This also gives you ample time to test all of your knowledge from thermos and fluids. First, we tried setting up a manual liquid cooling loop by siphoning water through a drinking straw. Then, we used a personal fan to apply the convective cooling more globally. Finally, when we could see the liquid wax starting to cloud up, we tossed it in the fridge to fully solidify overnight. Despite all of our troubles, we still came away with a good surface finish, and the best part, no one swallowed any paraffin. Now, Dr. Colton will always have a little friend to keep him company during his late nights at his injection molding machine. Finally, can we build it? I think the answer is yes. Yes, we can.